How's it going, everyone? Finally, after a couple days that I was hoarse, or my voice was hoarse, now I'm come back. And in today's video, we're gonna take a look now at what are the techniques that allow us to improve the performance of React components. So, because over the couple, I will say month, or the last 2 months, because I started this course in you at July 3, uh, almost 2 months ago, as a way to understand now how React works. Because if you want to improve the performance of something, you need to know how that thing works. So that's why I take a look at the React.dev, the learn section, as a way to understand what React is, what React allows us to do, which is describing the UI, and then how can we now adding interactivity to this UI or React components, understanding the concept of state in the React rendering cycles, as well as how can we now is updates objects, arrays, this thing called is state batching. And when it comes to manage our states per components, how can we do that? So by following a couple rules that they provide us, anytime you want is to create is your React components or any UI, or yeah, user interface. First, you need to understand that you are going to write your state in React, and then you notify them which state you want to be your application. So React will now match that state. So the React will sync that state with the DOM. So the way to do that is by first you must have is or the visual design or the data models, all right? Identify all the possible state that your application or your component can be, and then you're going to uh, determine what trigger those state updates, and then represent those state using uh, the built-in use state in memory from React. Okay, so each one of those states represent is a possible state that your application can be. Okay, and there is nothing wrong that you have a lot of states in your application. It's just the way of how you now is telling or giving a lot of this responsibility to this component, uh, and then you want is to now eliminate any non-essential state, which is now this is when the part of again React give to you is a couple of guidelines as a way to maintain your state clean. Also following is this database concept from normalization, which is how you can make your database or your data without redundant and duplicate data. Okay, and after you do that, then you're going to connect your event handlers that update that state. So this is pretty basic. This is pretty much how you can do that in React. All right, as well as when it comes to manage your state, how important it is for you to say, all right, avoid any non-essential states, avoid contradictory states, duplicate states, deeply nested object in your states, and organize states that are related to each other, or group states that are related to each other, as a way to say, hey, this piece of logic or this piece of states actually are together, or they have some relationship in your business logic. So with that, Then I also look at how you can now uh, define your states, and when you define your state. So, for example, you can is put an state in a components, how you can reset or for or reset or preserve the state in the components. React, after all, actually what it does is to type the state to the position of the render tree. All right, and they have this particular mechanism as a way to preserve the state or to reset the state. And when you need to, when a particular state needs to react, or the more inputs a particular state needs to react, it'll make much more sense to use something called reducers as a way to make your as a way to make your sorry as a way to make your state update logic maintainable. So that's quite interesting because uh, on that topic, then I look at what are the other things that we can do, especially for managing our state. So, for example, it's like if you need to pass down data to different components, you can do that uh, normally as passing props down there, or you can is using something called context. So context allow you to now, by having a one single file where you're going to define is all of your states that are shared across different components or distinct components, and by defining is the context, and in the component but that need use that context, and in on the top closest padding element define is the provider as a way to now make that data or state available to all of the sub tree children components. One of the caveat of this is that because React will re-render this component anytime in all of its children's, any time the value state updates starting from the provider. Sometimes you use optimization techniques like useMemo or useCallback as a way to catch computations between re-render or computations between function calls. So all of that is quite interesting, very, very, very interesting, because uh, we before using context, there's some recommendations that you can go with. So, for example, you can is or evaluate that you can evaluate if it is feasible to pass down data down the down the as prop drill, okay, or you can now is extract that component into a GSX and then pass down that data for that. This is one of the optimization techniques that we're going to see about in today's video. So now that we look how can we manage our state, and also how can we escape the hatches, which is by looking at how now we can make these UI components available to synchronize or to control external systems. So, for example, focus the input using the browser API, or play or pause the video in a in a player implemented outside of React, or you want is to connect to a server, okay, and start listening to message from them. You have now this particularly hooks. One of them is a useRef, which is pretty much like a secret pocket where you can now store some data. Most of the time, the data that you store here is timeout IDs, DOM elements or any other object that is not relevant in the GSX rendering. Sorry. Uh, and unlike the state, useRef doesn't trigger any state update. And also with the yeah, and also with the is it with the useRef, okay? And also with the yes, and also with the use effect. This is for any time you need to create a synchronization process. So because use effects allows to run is synchrony use effects, which are code that modify is the normal execution of your program, whether it's by altering the global variables, data structure, or perform input and output operations, ops. The thing here is that we are now being able to use effect, and it is important to distinguish two type of logic. You have now the rendering logic, which must be pure, and the event handle logic, which is when you can perform is side effects. So with this reactive logic, the idea is that you're going to now run this piece of code as caused or caused by the component rendering itself. So this will be now triggered after the commit phase, which is part of the mechanism of how React actually do what it does, which is rendering UI components. The trigger, commit, and the trigger, the trigger, render and commit phase. Okay. So after that, we also look at how can we start to use effects. So for example, there is a caveat, especially in development, because unlike previous versions, now in React 18, they use now this strict mode tag as a way to now is make the state logic and your effects run without any issues, or if there is, detect that, so prevent any bottlenecks there by re-rendering and running your effect twice. So this can be quite annoying, but the recommendations say the docs say, hey, you should match your use effect to start using with setup. Exactly, to start using with the setup cleanup and setup life cycle in development, because in production it only trigger is the setup function. So on that topic, the setup here, uh, on that topic, the setup or the anatomy of this use effect is that because you want to run this particular code after every commit, but most of the time we don't want to run that every single time. When the component render, we pass an array of dependency that indicate when this code will run. So most of the time, when you write your effect, it will fall into one of these patterns. Or you're calling to an external widget, Mapbox, Gearbox, for example, or you're calling an animation, or you're calling is, or you're synchronizing is to an event handler, okay, or to a most of the time to event handlers, right? So notification, so offline, online, and that kind of thing, for example, or scroll down, scroll up. You also want to fetch data, when things is this is when things started to get a little bit quite confusing. But once you understand that, is that pretty straightforward, because here we don't have the ability to stop or abort any network operation. We need to find a way to actually mimic that behavior as a way to prevent race conditions. So, for example, by on the setup code, we put is a flag uh, like abort or ignore. Uh, yeah, like we say, hey, ignore as false, and then we perform this the when then we fetch the data, we now check if that flag is false, so we can update our state. So when this code needs to rerun as caused by a dependency change, it will run the uh, cleanup function. When here we say, hey, any variables we define here, I want you to now, for example, the ignore, I want you to set true. So I want you to now ignore is the previous request, and therefore start with new requests with this new parameters or these new reactive dependencies. And also we need to consider some other uh, challenge, especially when fetching data. So for example, like duplicate network requests, because your effect doesn't run on the server, it runs on the client, and because of that, you need to first fetch this there. You need to first on the initial load, you need to first fetch the data from the client, from the server. The server render that data and send that to the client. The client show is an initial loading screen, and then it need to actually fetch the relevant JavaScript as a way to bring out reactivity, only to realize now that the component is shown to the user and is interactive, that it needs to perform is a network request. So you need to find a way to deduplicate this request. Also for catching as well, and yeah, for catching as well. Mm-hmm, mm-hmm. Also for catching, you need to find a way how you can catch your response in network waterfall as a way to prevent any time that this component mount, unmount, and remount, call that or make that HTTP request again. And this is not a trivial thing, pretty much like routing. So that's what we have, for example, is frameworks that take care of that for us. Next, Astro, uh, or client-side libraries that handle that for us. For example, React Query, and React Router, and use WCR. So that was quite interesting, by the way, as a way to recap that. And also, when it comes to identify when you don't need an effect, is that if you can compute this data, so if you have an state that needs to update based on props or states, recompute that. Or if you need a partial state, or you have a state that partially needs to update based on props or state, recreate that, which means is that do not use an effect. In fact, creates reactive variables. Also, if you need to, for example, uh, catch computations, do not use an effect. Use memo instead. And if you want to now perform several computation or chains of computation, do not use effect. in fact do that inside of the event handlers. And also, when it comes now to see how your effect works or the life cycle of your effects, is that because at the end of the day, effect was designed to start a synchronization process. So this is the two things that it does. It starts to synchronize with something and then later on stop it. So because of that, the linter provide you some useful hints as a way to understand why they do or why they're complaining the way they do. Because first, after all, we look at the anatomy of the use effect, the setup, the cleanup, and uh, the array of dependency, as well as when this actually is getting triggered. It is quite different to think about the components. So, after all, think of your effect as a way to synchronize your state. Mhm. Think your effect as a way to synchronize your effects, okay, or as a synchronization process, as they mention here. And uh, when you, for example, or the life cycle of this effect, when you need to start a synchronization process, you also need to define is the logic to desynchronize or unsubscribe, which is the cleanup function. So when the dependency changes, which is usually by looking at the using the object.is behind the scenes, okay, is that all right? It'll make sense, and you may wonder how now React actually detect when this dependency change actually changed by using as the object.is, and then it will now first, if this component is mounted, or if this effect when the component is mounted, your the setup function is run, and on updates the cleanup function is run first, and then with the all state, and then the setup function is run with the new state, right? And in one more time after the component is unmounted, then the cleanup function is run for the last time. So this particular life cycle here, and also understand how now React knows when an dependency changes. We lay down the foundation of what are these dependency that we can use in our array of dependency, because you can put there anything that you want. In fact, it must be something that it change over time, or reactive dependency. That's why, for example, here we have now is things like variables that we define inside of our component body, props, as well as states as reactive variables. And that's the only thing that you could have put inside of your effects dependency. So if you don't need that, you can define some data outside of the component's body and then make use of that. So the thing here is that the linter is gonna give you some hints as a way to prevent some common gotchas. And most of the time, when you need, for example, yeah, and most of the time, when you need, for example, is a way to update your React components. In this case, when you need a, for example, if your effects, okay, um, are uh, changing a lot or are triggering too much of your So if your effect dependencies are triggering too much of this effect logic, so there might be some issue there. You can reconsider is that you might not need an effect, or that you want to split this into a separate synchronization process. The other is, and I think this is something crucial and critical for your applications. The other is that sometimes you want is uh, avoid your, which is something that they're describing is here, and to me is quite interesting. What to do when you don't want to resynchronize your effect. The other is that when you need to read a value, props, a state, without reacting to that, you can use something called that is a event from effects. So way to simulate is these two logic, the effect logic, where it's gonna, so the event logic, the event handler logic, when it will be triggered based on a interaction, usually a user interaction, and the effects, which will trigger based on a change in a React dependency. So if you need to combine this, for example, you can do that, but this is still is in alpha, so I wouldn't recommend that. That might change, but it's important to understand at least is the core concept, okay? And that is that, hey, if you need to actually is mix these two logic, you have now a code that you want to run anytime a React dependency change, but also trigger some functionality based that you will define inside of your event handler. That'll make sense to combine it. But again, this is an edge case. It's still in alpha. The I wouldn't recommend it to go with. That's all. And the other is avoid putting objects and functions as a dependency, because anytime this component is re-rendered, those objects and functions are different. Therefore, React they're pointing to different position in memory, because anytime they're recreating that, that's exactly what JavaScript does when you rerun that function. So they're creating now new space of memory for this object and for this function. So you don't want to do that. So avoid that. Simple. Simple, simple. So we also look at separating event from effects. Just briefly describe that. What are the things that we can do here? Especially as a way to when you need to trigger some logic that is depend on an event, which is you want to trigger a functionality uh, when the same interaction happen uh, inside of your effects when a dependency change do. So you can use effect for that. Again, this is something that go still is in alpha. So I wouldn't rely to do this. I wouldn't recommend to go with that. We also look at how can we remove effects dependency, and this is by asking a couple questions. Is that if this affects when this mm-hmm, exactly. So for example, is this code should be in an event handler, or are we reading an state? Yeah, are we reading an state to calculate the next state inside of that? you you want us to remove the dependency and work with the previous state. Do you want to react to read values without reacting to change? Again, this is something that is still in alpha. It's an experimental feature. I wouldn't recommend that. And the other is that, does this React data change unintentionally? In other words, it now performs some uh, bugs or loops inside of your logic. So you might not want to do that. So, but this is a couple questions that you can ask as a way to remove dependency in your effect. Okay? Yeah, as a way to remove dependency in your effect, which is great. Which is great. Exactly, which is great. So now, then we look at how can we reuse logic with custom hooks. And first is, the idea here is to now abstract that logic into a particular file that you can make use of that when you return that data. All right. Hook names all, and we can also use the use as a way to indicate, hey, this is now is a custom hook or a custom logic here. And custom hooks or custom logic, uh, usually exactly. Custom hooks are used to share stateful logic, not state itself. That's what we have. For example, is uh, yeah. That's what we have. For example, is context, where in context they are useful to share that state for them. And here we look at how can we pass now reactive value to hooks, passing an event handler to hook, which is in construction as well, and when to use hooks. So, for example, if you need to, if a particular component actually is doing several uh, effects, what is triggering is several of these side effects code, you want to abstract that into their own. Exactly, you want to abstract that into their own data, for example. And similar to this. Exactly. So use data, cities, use data. So, but the point of this is that once I able to understand all of the things, then we look at how can we now, uh, uh, how can we now look at the performance techniques as a way to see when we have a bottleneck in our application, and how can we reduce in renderings. Tip number one is that you want to you want to push the state down to the proper components. So therefore, that states in that component, in the parent component, actually is not triggering is all of this rendering. You are pushing the state down to that, so you are containerize that state as a way to now trigger is rendering from that position. The other is that pulling the content, okay? The other is that make the render tree smaller in that component. It's like, hey, you want it to, for example, now, exactly, this is another tip. Make the render tree smaller in that component. Hey, if you're actually rendering, or in this part of the component actually using a lot of other components, find a way of how you can now abstract that, or make your React components GSX smaller as possible. Okay, or not smaller as possible, but small, to prevent to rendering them. The other is tip 3. Putting everything down in the tree is free. Okay, using memo a lot, it can slowly become a problem. We don't want the medicine to be worse than the disease. uh, and this is now pulling content up with children as a way to say, hey, this is another technique. So first is, I think this is pushing state down. This is one particularly rendering the optimization technique. Hey, is this a state as well as the GSX tags? It's gonna put that down there, right? Uh, and the other is pulling content up with children. It's like, hey, well, if we need to actually pass down data to that component, instead of actually passing down to those components, this is another thing that we can do. Is like, let me now abstract that component, all right? Or in this case, it's like, let me now is pull content up with the children, which is something that we're about to do here. Pulling content up. PM came here and say, I love what you did there, but the sign thing needs to write between the color swatch and then guessing. So let's get into this. It's
All right, so a
yeah. Right now you're not gonna see what I'm doing, but I'm gonna take notes out of this course and put it there right now. Is it?
product manager came in, and they're like, I love what you did with the expensive component down at the bottom. But it turns out design really wants it right in between down at the bottom.
Okay. I think it's this. What is this? Point counting up exercise. Oh, it's because because it's warming. Oh, okay, there you got it.
But it turns out design really wants it right in between those two pieces, right? They want it right in between the color swatch and the guessing, right? So the immediate way that we would normally do that, which is again a completely reasonable way to do it if this thing wasn't a problematic component, right? Like in a real work, like I love the case of rendering a 3JS thing. Like that's a thing that you don't want to do too often, right? We got to put it in the middle. So the obviously not great immediate thing that we would do, especially is imagine you were not the developer that pushed that state down previously. You're like, oh, it needs to be in the middle, and then let's say it wasn't called expensive component, with an obvious issue. You might be like, well, okay, cool. Here's what I'm going to do. I'll just go into my game, and I'm going to put it right in there, just like the design team asked for, and everything's going to be great. And
No.
those of us who worked on the original feature, we know that that's literally the problem that we just solved 2 sprints ago. And here it is again, but it's got to be in the middle because that's the new product requirements, right? So it's we got to put it there. And okay, cool. I don't remember which one it was in between, but the point doesn't really matter. Application, once again, ridiculous. And so is it just that we tell this comes down? Do we do that thing where we have to figure out which hill we want to die on when we push back on product requirements, or again, the name of the game here is not immediately reaching for memo and just using and understanding using React before we pull for all these tools, right? So yes, I understand. Also, you can put memo on this one. But doing that all the time adds up and pays its own costs. It's like all your performance problems normally were caused by like a bunch of things that didn't really matter. It's fine, accept my pull request. The sprint's ending tomorrow. And like the same thing happens with 1,000 memos over time. Trust me. So we want to take this technique where we want it to show up in between those two parts, just like design asks for, but we want to actually follow the rules of React's component hierarchy and not have it re-render every time the state happens here.
Oh, okay. So when we can do this is by okay. So far so good. Really? Hmm. Okay. Cheat sheet. Yeah, that's right. File management. Navigation. Oh, I need that in Mac. File management. Navigation. Okay, option. For control. Interesting. Wait, what? Move to the next step, but where is it? Move active editor group, but this is move active editor group. Move active editor group. Okay, I love it. Okay. Yeah, but you don't mention that. It's like, what in the fucking hell is it? I love it. Move to the next tab. Anyway. Okay. Move to the next tab. Okay. And then, okay. So PM decided to say, hey, you know what? We want that component to be rendered here. So what are you gonna do? Because we want us to actually comply what the PM says and also what the React rules are. So one way to do that is by now pushing the state down the tree. Okay. It's like, hey, I don't want you to now re-render this. Exactly. I don't want you to re-render this component. Okay. I don't want you to re-render this component. That's quite interesting here. Based on everything that you have learned, how can we do that? So instead of actually putting in some memo for that, okay, we want to comply with the React rules. So one way to do that is by say, let me actually take a quick moment here. How can we tell now React to say, hey, despite having all of these components, I want to make this component not get rendered when a state update change. You can use this memo, okay? Or you can use some of these techniques that we have looked so far, which is preserve and reset the state. So
happens with 1,000 memos over time. Trust me. So we want to doing that all the time adds up and pays its own costs. It's like all your performance problems normally were caused by like a bunch of things that didn't really matter. It's fine, accept my pull request. The sprint's ending tomorrow. And like the same thing happens with 1,000 memos over time. Trust me. So we want to take this technique where we want it to show up in between those two parts, just like design asks for, but we want to actually follow the rules of React's component hierarchy and not have it re-render every time the state happens here, right? And so the way that we do this is kind of like, as words aren't great for, but hopefully that the chart will make more sense. I'll like re-show it to you afterwards. We try to part this game component for a place where I can put it in between those two.
Okay. Another thing. Okay. Another technique that we can use here is that by now putting this component here, that'll be great.
Things, but actually spiritually keep it up top where I wanted it before, right? So we basically want to show it in between the color swatch and the inputs or any of those.
So because when we run this npm star here, all right, as you can see here, exactly, the input is deadly slow, okay, but we need to somehow is to actually make this component here, keep that component here, but in a way that actually stay what the design team needs to, as well as keep or follow the React rules when it comes to render components. So by now is doing something like this, which is, hey, I want you to now render is the children, where now the children here will be is whatever we are receiving here as children, okay, and here this component, technically speaking, doesn't belong to, well, technical no, is this component, this expense component doesn't belong to this level. It belongs to wherever we inject that. Again, remember that after all, the state is tied to the position of the render tree. So by rendering here is the children, for example, here, it say, yeah, but I don't have any children here. It's like, hey, I don't have any children component here. Okay. And then do something like this. Right now you're not able to see what I'm doing. Let me in fact share my screen here. this one. Okay. So because here we are now rendering is this component here, like so. For some reason, well, the design team, now that we identify that this component is expensive because it's rendering over and over and over, or it's having some blocking operation here. And how do we determine that? By take a look at the profiler. That's one of the. Yeah, by take a look at the profiler. Yep, by take a look at the profiler. But take a look at the profile, and because the PM decided to, hey, this is the component that need to leave here. I'm sorry if you don't like it, but this is the product that we need to build. So one way to say is to, you can say is, or if you want to this component render without altering this component. So there are a couple of things that there are a couple of techniques that you can do. You push the content down the tree, followed by it is states if they have particular state related to this, all right, or you pull in the content up, which is instead of actually letting this component be rendered at this position in the render tree, we want is to now make that components to be rendered is at the top component for that. So here we're gonna pass this as a dynamic component that is going to be rendered here. And here, when we take a look now at this and say, hey, we actually solve a particular renderization problem. These two techniques are very, and this is the reason why you have to pay for your, this is the reason why you have to pay for that. This component is rendered as expected, but it's not causing any time that this component, in fact, let me actually highlight this. But it's not causing, as you can see here, even though that this component is now rendering is here, because we're following is the React rules as a way to say, hey, we want this expensive component be rendered here, but this component doesn't belong to the game. And you may wonder what, but actually it is. I don't know. These components, in fact, is being passed down as dynamic content to that, which means is that this component game only have color swatch, game input, and game status. Whenever the state change at that level, it will now cause that cascade effect. But because this component was injected at this level, at the application level, it not causing that component to be rendered. Holy moly with this technique, man. Holy moly with this technique, bro.
Those two components. But as far as React is concerned, isolate it just like as we did earlier. So what we do here is we would not put in this component, because that is just literally undoing our refactor in every way possible. But we'd say is like, hey, game component, don't worry about what happens in here. It's not really your child, but just leave a slot for me, the parent component, to do my thing and render a component in here, right? Like, don't you worry about it, right? It's not part of your tree. It's still the parent's child, like it's your sibling. But we pass it in, like, just give me a place where I can render something else, okay? Like, Svelte calls these slots instead of children, which probably like would make this entire conversation a lot easier, but so I can render something else, okay? Like, Svelte calls these slots instead of children. which probably like, but we pass it in like, just give me a place where I can render something else. Okay? Like Svelte calls these slots instead of children. Which probably like would make this entire conversation a lot easier. But like that's what happens when one framework is like 8 years older than the other. It's not probably not 8 years older, but several years older.
Components and
What's
view, web components and view and etc. Use
So
slots,
everything, but
slots
yeah.
as well. Yeah.
Not just the only other one that I use, but you're saying that all the rest of them, right? Cool. And so we'll just part the C's of game for a moment. We'll put back in expensive component, which is still now, like it looks a lot clearer in code, like whose child application is, right? It's applications. It's not really games. It's happening in between two different parts of game, but like when React is running through and it's running through application when it sees that component, right? That is where it's listening to say, yeah.
So technically speaking, is this valid to assume that whenever the component, no matter how many levels deep it's specified as a child, it still belongs to the very outer component in which it was exactly declared? Yeah?
Yep.
Oh, so even we had 15 layers, doesn't matter,
Yeah.
still belongs to
I think the heuristic is like it belongs to the file it's defined in.
Yeah, right.
Okay. Tip 4. The component or the heuristic. The components belong. Exactly. The components belong to where.
Very outer component in which it was exactly declared? Yeah?
Yep.
Oh, so even we had 15 layers, doesn't matter,
Yeah.
still belongs to
I think the heuristic is like it belongs to the file it's.
The component to the file it was defined. Why this is important? Especially as a way to reduce re-renderings without using memo.
Find in.
Yeah.
Right? Like, regardless of like where it shows up in the DOM, it is in the component tree, literally where it's written, more than like where it shows up in the DOM. So we'll have this in place, and we'll save it. Oh, everything's great again, right? And we can see we don't have that slowdown again. And so that is a way to both, we can either push state down, or if we need something where it's got to be in the middle there, we can pull the content up. There are variations on a theme, and they both work equally as well. And like I said, like, you know, like I will use memo, and I use memo all the time. But like like responsibility is to like show you that like you don't need those as the first thing that you reach for. Sometimes just understanding React's component hierarchy will get you what you're looking for before you pull out like the kind of like bigger tools, right? I say this as the person who uses a power drill when I open up furniture that says do not use with a power tool, right? I get it. I am that person myself, but like I have to play a role today. So I do, like one of my favorite things about this workshop so far is that people are asking like some of the questions like before we get to it. And so we talked a little bit about React Memo. And I want to, one of the questions that we saw, we talked about, but we didn't like look at it in action, was like, okay, we're moving like expensive component around. And again, on purpose, right? Because again, like step one is, can you just work with your component hierarchy in a way that does not involve extra checks? Yeah, one extra check is no big deal as they add up, right? Like performance problems. But sometimes that is the strategy. It's like, as due diligence, you should see, can you do it? Can you solve your performance issue without, like, you know, it's not, I wouldn't say it's like using like a like exclamation point important on a CSS tag. It's not that. But like, the metaphor has its virtues. But it is a thing that works. And like, we'll talk about it in a second. But let's see it first, and then we'll talk about it. So this, I grabbed a previous, one of the earlier bad ones, right, where expensive component is a sibling and it is causing all the problems that it likes to cause. I think it's still living over in game too, but it's not being used. The joys of switching Git branches repeatedly in a way that Git was never meant to handle. So let's go take a look at that. I think it is, yep, it's up in 3001. And we are slow. And there are, like we said before, React is doing its thing. Parent re-rendered. Every child is asked to re-render. There are like most good ways of doing anything. There's a way to be like, hey, listen, I know what's going on here. Stand back.
Okay. Okay, so one way to do this is by, okay, as a way to solve this pulling content up solution.
I got this, right? You know, like, and so React.memo is basically, like we said before when someone asked the question of like, it gives you the ability to hug a component, right, with some logic to like look at the props before they make it to that expensive component. Like we were moving stuff around so that like new changes didn't make it to a component. This is a way to be like, let me see that first. And there are different ways to do it for class-based components versus function components and hooks. Should component update method on a, you can wrap a class component in React.memo too. So it's like, should component update, and there's another one for functional components are unique to both of them. React.memo and wrapping the component works on both, but there's other ways to do it. But they all predate React.memo, and I would say at this point this is the preferred way to do it. If I was dispensing advice on best practices, my version of a best practice. And what it does is it hugs it and checks the props, and then does not re-render it if the props are the same as last time, right? And particularly for expensive component, which does not take any props, they are always going to be the same, because like empty is the same as empty every time. Right? Does null equal null? Like it's one of the final truths in JavaScript where things don't always make sense. And using it is very easy. Put a space for that autocomplete niceness. Memo, it's on the React library, and you wrap it. Memo does theoretically take a second argument. Let's see if we hover over and get the type information. You can see right there, props are equal is a function that takes the previous props and the next props and returns a Boolean or undefined. Exactly. You can take a lucky guess. Like what it does right now is does a shallow comparison, which it looks at like the first property. It doesn't like, if one of those properties is an object, it'll just say like, is this object the same as the other object? It's not going to go recursively because deep equal is shockingly expensive. And if you want to find a way to make your performance issues worse by trying to solve them, I worked on a team where they thought you had to do that to keep immutability in React and use a deep equal on every single set state. That was the first time to solve them. I worked on a team where they thought you had to do that to keep immutability in React and use a deep equal on every single set state. That was the first time I got to use a lot of these tools, just repeatedly. And so yeah, it wraps it and like gives you your own ability to check to see. Have I ever used that before? Yes. Was it like 4 to 5 years ago? Of course. Do I remember what the issue was? Absolutely not. Right? I think it was like I really only cared about like one prop or something like that. Right? And the rest were irrelevant and possibly could change, but like only one thing mattered. I don't really remember. It was not my favorite day. Right? It was one of these things. I guess I'm doing this today, kind of things. So you can pass the second one in recent memory. I have not had a particularly good excuse to do it. So now, we're exporting as default, so we can still call it expensive component anywhere, but it's our hugged expensive component, right? So it's not the same expensive component as we had before, and unless it gets new and different props, which if this was TypeScript, it definitely couldn't because the compiler would yell at me. JavaScript, I'm sure I could manage it, but ideally it shouldn't get it. But at least it's not going to get it on every render, and things will stop. So it can sit where it was, and we should be good. Should just go back and see. Look at that. You just wrap it, and yeah, there's a slight cost to that. But like in a lot of cases where any of these other techniques aren't available to you, it's a valid way to do it. But it should not be the first thing you do because again, it's not necessarily free. And as the golden rule was, not doing stuff is faster than doing stuff.
Not do stuff. Yeah, as one of the golden rules of performance is that not doing something is way much performance than doing it. It's way much faster than doing it.
Right, and like, there's always like technical answers, right? I always think about it as somebody who like leads a team too, which is like the second you start that, like then everyone starts doing it. The next thing you know, you're taking components that don't even have subtrees, and just everyone's like, well, that's what we do in this code base, right? And things get out of control, and sometimes you need rules. And so, that's a thing.
Memo. There's a way to memorize this. Skipping re-render when props are unchanged. Skipping re-render when props are unchanged. So for example, this. Hey, as long as they are unchanged and useful for components that they don't receive any things like that, but they are doing expensive stuff. So yeah. So you wrap that component there. Updating a memory component using state. With props that are passed to the component from its parent. Exactly. Exactly. When you need to re-render this component, it will be called. We're in selector here because now it's updating the state here. That's what happened. It's being called here. But when, for example, only you change name, of course it will be called. But address does not. As long as there are, so skipping re-render when a prop changes, updating a memoized component using a state. So for example here, and I want you to update the state of a component when that change. That's when we wrap them as memo. It's a memoization technique. Updating a memoized component using context. Again, the same. So when that context change, but as you can see, the name doesn't change, but the component is still re-rendered. because that's one of the problems that happen here with context, is that it will start to it will React will re-render all the components, and all of the children that have access to the context, starting from the provider, in this case here, that value change. So if this value changes, it will now call this, and all of these components and all of the children that make use that state, starting from the provider. So for example, is calling the greetings, even though that the component hasn't changed, but it's because the theme changed, especially when they change this. Even though, for example, if we remove theme, for example, and then we say, hey, this is light, light. Okay. What will be the output of this? Well, because this component is not making use of this, because this component is not making use of this, when you switch the theme, which is now there, you are now, so React will render this component, in fact it will render the greeting as well, but as long as they make use of that context. Therefore, you shouldn't, exactly, you shouldn't actually is change that. You shouldn't change that. Even though you're clicking here, unless you for some reason want to show this, let's say theme, okay, unless you want to make use of that, then you, exactly, but it's only those components that make use of that. It's only of those components that make use of that context. Minimizing props change. Your components re-render whenever any prop is not shallowly equal to what it was previously. This means that React compares every props in your component with its previous value using the object.is comparison. Note that the object.is 3 by 3 is equal to 3, but this is false because those objects are having different reference in memory. Minimizing props change. Exactly. Avoid to recreating them.
And so that's in place. So let's okay, for all those re-renders in the other app, right, that packing list app, and we guess 3002. Yay. We had all the crazy, we fixed it there. We still have it. Just for changing one, we'll re-render everything all the time. So ideally, what I should be able to do is just slather on some React memos and all my problems should go away, right? Let's do it. It's not a big app. It's not going to be that bad. All right. So application, the general structure of this app, application has that new item, has a mark all as red button. The real two things are two lists, one for packed and one for unpacked items. Those then have a series of items, right? Not a lot going on here. So what we'll say is, listen, item list, if you get the same array of things, don't re-render. Memo. I got to import it. Meme. Not important how many times I've done that. And then a given item on the list, especially because you imagine the list will probably change, right? If one of them gets its name changed, that's going to remap an array. Arrays get changed all the time. And I'm going to just say that one more time because when we talk about some of these other memoization things, if you ever memoize something where you're using a map and returning a new array, right before that, then guess two arrays with the same things are not the same array. And this is why using the tools and looking after you do something, a lot of times 95% of the time the thing that you think would happen happens. Notice I said 95. Just memo everything. Let's go for it. This is, I think in a lot of cases what a younger, not as handsome, but more naive version of me, I've seen pictures of myself from a few years ago, and would have done, right? Which is this, I'm going to do this everywhere, right? And would find out later. There was one time that I was definitely a contributing factor in the problem, right? Because it's yo, this is what I'm supposed to do. And it's before I had come across my own now adage of then if that's true, then they would have just done it in the framework, right? This isn't just a fun little a little chore they let me do to make me feel like I was important. So I think I got it mostly everywhere. I didn't get it in header. I can see because it's not a modified file. We're just making a point at this point. So yeah, memo, toss it everywhere. It'll be great. And so now things shouldn't change, right? I should be able to I don't know, edit the name of one of these and it shouldn't affect this array. Nothing is better. Everything is still as bad as it ever was, right? In fact, I could literally do something silly to make a ridiculous point. Let's do it in the actual thing. Let's say nothing important. And we'll say yo. After you load, wait a second, and let's just flip it to true. Let's just change literally anything, right? So you don't go well, actually, maybe because you changed the name of one that.
This is a way of how you can actually check if everything is.
Wait a second.
Actually work as expected.
I'll act like I know how useState works for a second.
I was going to say, well, I've never seen that implementation before.
This is why. I'll act like I know how useState works for a second.
I was going to say, well, I've never seen that implementation before.
This is why. How do I put this? This is one of the problems that I have now, which is sometimes I will have a mistake in a PR, and someone will be oh, well, I thought you did that on purpose. I'm no, I'm just an idiot, right? I was just tired. It was just the end of the day, and I thought it was responsible to push up my code before I made dinner, right? Cool. And so let's go ahead And you can see that in that second, the entire app, nothing to do with the items, re-rendered everything. Right? So just me following that blind advice and going for it didn't, I mean, maybe something didn't re-render that before, but like generally speaking, yeah, it looks like packing list was fine. Like the number of items, that one was fine. And I'm pretty sure that was it. Everything else re-rendered. I mean, I literally have tools I could see. I gotta hit that one, it'll refresh and do it. Cool, everything re-rendered. Why? Why did everything, well, I can find out why, that's good.
Everything's re-rendered. Well, initially on the, because at the initial render, well, everything will render.
Oh, that was the first time. We want the second time, a second later. Oh, look, the tools tell me. Props changed. It said, like, React Memo was doing his job. It's like, I will not let this component re-render unless the props change. You know, I told that story about how I wrote a custom one. I don't remember why. I don't remember if I was doing something really dark that I shouldn't have. Now I have this like sudden existential set of dread. I was like, but ignore all the functions, right? Which in class-based components might have been okay, but closures are a thing and hooks, and like you would have the wrong variable in there. Don't do that. I don't know if that's what I did, but like now I'm worried that like whatever thing I did 4 or 5 years ago was potentially terrible. It was pre-hook, so it couldn't have been that bad. It might not have been that. But yeah, we can see update and remove are the reasons that everything is changing. And again, like, here's the thing. JavaScript exists. Sometimes we forget that, but it's still a thing. And like, it's not even bad. It's just like there are rules, right? And if we look at this, like we have the eternal problem, and I kind of did the thing where it's like, you have to like mention whatever the murder weapon was in chapter 1 if it ends up biting you later. Which is like we have all these helpful things of like, cool, 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 yeah, make an item with the right properties, great, great, great. Here's the one that like maps through the array if it has the right ID.
Oh, okay. Especially when you are setting your, okay, when your setting is your state.
It updates it. All this stuff that you have to do with immutable data structures that now we just live with. And
because you are recreating is the state.
This one filters out if it doesn't have the right ID, but it didn't have the ability to set the items because I don't have that until I'm in this function, right? So what did I do? Cool, I just wired them up. Life went on. However, like almost like what we saw in the very first time, right? This, despite the fact that it does the same thing as the last time this ran, is a new function in memory, right?
Yeah.
And in JavaScript, like when I say there are rules,
Yeah, completely.
it's like 1 equals 1 totally. Depending on how many equal signs you use, 2 or true can also equal 1. But generally speaking, if we stick to using 3 equal signs, 1 will equal 1. A string will equal that same string. Like primitives are passed by value. Objects are passed by the reference in memory, right?
Exactly.
So 2 arrays with the same
Now,
items
what happens is that
are different
as
objects
you
in memory,
describe it
thereby
is
they're
that
not equal.
anytime
Same
you
is true for 2
describe it
functions that
this,
do the same thing.
you are
They're
recreating
different memory
this
addresses,
function.
and thereby are not equal. So
And because you're
when
recreating
React.memo
these functions
looks at this function that
here,
is,
and
in
you
our
pass
eyes,
down
the same
to any of
thing,
these components,
and the one I got last time,
then anytime
right?
it renders,
It's like, well, these are different.
alright.
Because it's a computer. This is why I'm not worried about like robots
So what
taking
you
over
can
just yet.
do here is
Like
to say,
let's deal with things like this
All
automatically,
right.
and then I'll worry.
use
last
the
words.
memo for that.
So like these are different values are stored. So it compares this function to another function. Different memory addresses we're assigning out each way through. Okay, the rules of React.memo apply. Everything works, right? It's like the code works, just not as you expected, but it works. So we clearly need like a few more tools in order to handle this, right? And React has those tools for us because this is obviously like, why would React Memo exist if you used hooks and thereby it wasn't a thing? Interestingly, this is not as much of an issue with classes because methods are the same. They're the same function attached to that object on the prototype, right? So like point for class-based components, that methods are the same object in memory every time. You're not redefining them. Unless you do like some of the modern stuff, like where you're like going to assign it to like a class variable, like unless you do the kind of class components I was writing before I switched over to function components, where I was just opting out of most of the goodness anyway. But generally speaking, React has some tools to help us with this. useMemo, not to be confused with React Memo, and useCallback. Right? You've probably heard of these before. useMemo is a way to say like, It's like useEffect's friend. It's like if useEffect and useCallback were hanging out with each other. It's saying like, hey, like generate random number. That was an expensive function, right? And let's say it took some arguments. It's like if all these other things that you rely on are the same, don't run. Like if you have a pure function, the idea of a pure function is like if the same inputs go in, the same value comes out, right? And you've seen these, like these are the same inputs you saw as the last time. We don't need running again. We know how this story ends, right? So it's great for any kind of expensive value that you might be running. You can even use it on components and stuff like that to like, okay, we run it, we've got the component rendered.
Exactly.
There's a bunch of like interesting things you can do with it.
Anytime you define a
Probably
reactive
more
value,
commonly is useCallback. And
that is
useCallback
not
is,
or a state, which
I'm going to
is
hand this
a
function.
value.
It's clearly got like set items
What
from a
happens
closure
is that
scope,
object
right?
functions,
And like you definitely need to know about that. And
anytime
items more
React
importantly, because if you're going to push onto the array,
re-rendered
if you have an old copy of that array,
because using JavaScript,
you're going to push onto an old
you're
array,
running a
and now your state
function,
manager is going to get all
you
weird.
are
So if all the things that you
recreating-
rely on are the same, don't whip up a
So
new
if you
function.
define
I
a
held on to the
function
one from last
or an
time. This is
object,
kind of like when we
what
saw
you're
like
doing
with
is that anytime
useState throwing that
JavaScript
initializer function on the floor,
re-render
previous
or
values on the floor.
call
These
this
data structures in
function,
the React fibers
anytime
like
you
are
call
familiar
that,
with like what happened last time, even if you're not.
or
And it's
it
going to
will
say like,
call- it will create
if
a new
I just
space
looked at all
in
the things you
memory
said that this thing cares
for
about, they're the
So as a
same.
way
So
to
I'll give you back the
prevent
one
that,
from last time, right? And that will actually
okay,
get you the same
that's when you
memory
wrap it
reference to the
into a
function,
memo
and then make
or a
all of this
callback.
work. So we can go ahead and like, becomes basically as simple as like, use callback. We can wrap the function, and we give it that dependency list. Really, the only one we care about is items.
Use height.
And like you'll notice that like ESLint doesn't yell at me for not having set items. Would anyone like to venture a guess why? Yeah.
Wait, what?
And like you'll notice that like we can wrap the function, and we give it that dependency list. Really, the only one we care about is items. And like you'll notice that like ESLint doesn't yell at me for not having set items. Would anyone like to venture a guess why?
Wait, what?
The only one we care about is items. And like you'll notice that like ESLint doesn't yell at me for not having set items. Would anyone like to venture a guess why? Really, the only one we care about is items. And like you'll notice that like ESLint doesn't yell at me for not having set items. Would anyone like to venture a guess why?
Oh, because that is not a reactive dependency.
Yeah.
Just because it's still within the scope, right?
Yes-ish. Like because this is just setting it, like React is already actually using effectively useCallback to give me the same version every time. This one is not changing. I am getting a same memory reference every time to set item. But items, I'm literally redefining it all the time. Like the only thing in this app is items. So by definition, those are regenerating every time. But this is saying like unless items has changed, like I don't need you worrying about this,
Exactly.
right?
Because
And so useCallback will kind of give you the same thing as long as this hasn't changed. Now, like we said before, most of the time that is like the thing that changes in this application. Like I could pull back up the draft item. I could go put in that ridiculous code that I had. Like this is mostly to kind of show you the demonstration of why it didn't work and how it can work. But it does it is the kind of solution for this problem. And like for this one, especially for functions which don't change, like this is a pretty safe and reasonable thing to do, especially if you are creating custom hooks yourself, right? In the same way that set items is static every time, I would expect that if I got some kind of setter function from like either a third-party hook or one that we made, the same principle would be there, right? Like this is a thing that, yeah, we're binding them together, awesome. And I'll show you how to not do this in a second too. But for the most part, like this, I think is under the things where it's like, I think this is definitely a fair and safe one to do because like you're not getting any benefits by whipping up a new function every time either. So, gotta give the root list. Set items. And then you could be like, I should use useMemo on these. It's tricky because the only thing in this app that could ever change is the items. And so like, if there were more things and this was expensive, yeah, totally, go for it, right on. But doing that when you get no benefit is just pointless, right? Like, and like, so some of this stuff is like, if the answer was always yes, it would happen for you. Like they would just do it. Yes, Mark?
So you recommend using useCallback instead of useMemo due to creating of the new functions?
So you use them for different cases. If I wanted the value, to be persisted unless things change, I use useMemo. If I want a function that's the same reference every time, I use useCallback. UseCallback is for when I need a function. useMemo is for when I need a value. It's just basically, do I need a value or a function? If I use useMemo here, I would get the result of this, right? Not the function itself that I want to pass down to items. So like, items are the ones that will pass in the ID to remove them. Yes, Mark?
Will memo work with nested prop changes?
I think it's still a shallow compare. I'm trying to remember if it takes another argument. I don't think it does. Like it's like in the same way you saw that like React.memo took a like is no. I think it's just looking at the highest level. But you could say object.property if you only cared about one property of that. It's like the nice part is that like ESLint will do both for you. If you have it set up, it will both yell at you when you're missing something. I think, if I'm not mistaken, sometimes yell at you if you pass something that's not going to change. I have been yelled at by before, but we'll tell you. But like generally speaking, the things that you actually like, you basically you can have static analysis do it, or you can look at your own code. Like what are the things that you're calling that are coming from outside the closure scope? So obviously, there are. This exists statically because I'm importing it. These two are arguments. It's really items and set items that could be possibly. Like, I think if I put like update items in here, I'll get yelled at. Yeah, you can see like React hooks useCallback has an unnecessary dependency. Update item either excluded or remove the dependency array. Other outer scope values like update item aren't valid dependencies because it doesn't re-render the component. So like you get a sense of like what the right things are in that sense. You can have the tooling help you. You can put it through all these. Should have kept that surreptitious function in there, but we'll do it in a second. But these are now unless items changes, which is a thing that happens a lot in this particular app. If I put something else in here, like a timer or something like that doesn't change it, these will stay the same and they won't trigger a re-render, right? Yeah.
So, technically speaking, if the function does not have any effect, and it technically is a pure function, and you're interested only in the output, you use memo because you don't even need to run it anymore, right? And in cases like this one, you have some sort of effect where you're mutating state or doing anything else. You use callback because you're interested in the execution of the body.
Yep, exactly. Right. And the important thing to note is that like this is only if I want these helpers. If I was comfortable passing down set items through the entire chain or dispatch on a reducer, like I said before, those are the same value every time. It's only because I'm whipping these functions up on the fly up here because I need to for some reason. Maybe there's some information that they need up here, something along those lines. Then I do need to like just say like as long as the things you rely on, as long as the reason why you're up here hasn't changed, like be the same one. But like set items itself, dispatch on useReducer, stuff along those lines, those are static every time. Like they are the same reference. Like this has already been done to them because they're just updating that data structure inside of React. They have access to the full history of things. They know everything. They don't necessarily care about what's in this current closure scope. But like if you define the function here, everything in this scope is accessible to it. And if those variables have changed, you're going to get an old version of the function that knows about an old world. There was like when hooks came out, it's like you traded all of your class hierarchy problems for closure problems, right? It's so much simpler, and now you have a new set of things to work out, which is how closures work in JavaScript, and will occasionally bite you. But like this will always be whatever items was at the time it was written, not what it is eventually, right? And so this says like if items changes, throw the old one out and get me one that knows about what the current latest and greatest version of items is. Right? And since we immutably change things, if we had mutable state, that it would be the same thing that we were modifying. But like we've long since either like discarded it or actually garbage collected it. Well, not because there's a closure scope. But like generally speaking, it will be an old version of that variable. So this is a way to say that's totally cool because I want my React.memo to work. But at the same time, if that becomes out of date, then go get me a fresh one, right? Which way you do need to pass a new thing down and have all that kind of work. And this is true even with the context API. Right, because the context API is just basically pulling this out of the function and like letting places hook into it, but like all the same rules apply in this case as well. But this is a powerful way to get functions that we find that will then work through React.memo. I should put back that silly function that I wrote earlier. Did I save it? No. So we'll just say cool. Set a timeout for a second. here we'll flip over. And just so we make sure we're keeping ourselves honest, the application re-renders, right? You saw the big box around the entire thing, because that's where we're changing that state. No, that should, but nothing else re-rendered, right? Because those are still the same update and remove. They're getting passed all the way through. Like I said before, if you just wanted to pass set items all the way through and then figure out everything else down at the bottom, that also works and will save you the use callbacks, right? You just import all these functions in all the different places that you need to. And I think that works if you're just trying to get it down to like one grandchild, great-grandchild component. If you find yourself needing it various places along the way, now you're just importing stuff all over the place. Now it becomes like, is it performant? Sure. Is it code that you can maintain? No, right? And one of my hot takes is that, backend services, when they don't scale, it's because the database falls over under load and stuff like that. A lot of times with front-end code bases, since we do manage just like tons and tons of state, it's that like all of a sudden when we get asked for a very simple feature, we tell them 3 months. It's because like sometimes we over-optimized for different things, and now maintaining our own code base is borderline impossible, right? And so like sometimes it's about like thinking about those trade-offs in that sense as well. But yeah, these are static, but like any function that you make like along the way, if you don't like deal with it, like, or either wrap it or then do these techniques where you're just passing things and then like importing the other pieces where you need it, like you will end up breaking your own React memo, and then also paying the cost for that React memo in the first place. It's like you get the worst of both worlds. You're now doing the comparison all the time, and it's always failing, right? You might as well just take it, like it would have been more performant without the React memo on it at that point, right? Because like it would have been re-rendering anyway. And so it's like that's where sometimes the measuring is important, which is, sure, try it out, like absolutely, put it on there. Try to guess what future you is going to have to deal with, right? Because you can't measure future use code right now. But then like make sure that you're actually getting a gain, or make sure that it's stopping anything. Because if you just blindly take it as like advice, like, and you just go for it, like you could literally be making the problem maybe not dramatically worse, but over time, incrementally worse, right? Until you then have to like, and it's a lot harder to triage like why a bunch of like implicitly memoizing stuff is slowing stuff down than just seeing a prompt shoot all the way down through. So you get a harder bug to solve. Also, the idea of caching stuff when it shouldn't be cached, you take on not only a performance risk, but you also take on a little bit of a weirdness cache invalidation problem miss where you now have a weird bug, right? You're playing with a little bit of fire. That's why component hierarchies first, right? Stuff like memoing those things are there for a reason, right? Absolutely use them, but like we try to do our due diligence as we're going through, and we try to understand the problem and see what our options are that are available to us. Awesome. So like generally speaking, let's look at, if I take out my silly code, let's use the app a little bit. Like there's still going to be a decent amount of, because there's really only items in this particular one. We'll play with some other ones in a little second. But like if I edit one, it's a lot of things. Like new item name, is that one rendering? That's interesting. Do we put it on that one? Because that one should not, right? That's one we would like to see stop at this point. That's interesting. I'm curious why. Oh, it's getting add item. Do we have a use callback on that one? That one should stop. Let's take a look.
No, because you didn't add item.
Interesting. Let's make sure that's actually happening. Well, I'll take a look at it in a little second. Let's triage it. All right, so we saw header. Oh, it might have just been the one above it and the one below it and the shell around the side. I can tell that like I saw the green thing. I was like, is that rendering? It's clearly not. Like the two lists, which are theoretically the same list before they're rendered. And like, let's talk about that a little bit too, because I think there's an interesting point there that is a tricky problem to solve. Like the only things that are item list props change, update, remove because items change. Like everything's actually at this moment working as expected. This is where another thought exercise that like literally considered and thought about and then opted not to do because I think that it's probably a bad idea. So these packed and unpacked items are generated on the fly, right? They're generated from taking the overall list and you filter them, right? If there were a lot of changes that didn't involve them moving back and forth between the two lists, right? One thing I could do is I could wire up my state management in a way that had two lists, right? And then I would manually have to shuffle them back and forth, right? And you'd want some unit tests for that. Like even in that simple example, you'd want some unit tests, and then I could then memoize, or have things based on each of those. But then I'd have two of each of those add, update, and remove functions, and I would have to like do the act of shuffling them back and forth. And sometimes, like, one, I don't actually know if that all that extra work and having double of everything and volleying stuff back and forth is worth it. And two, the complexity cost is also probably not worth it for almost no performance gain, right? But again, you have options, and to like always reach for one thing blindly is probably like at least slightly problematic, right? But you can also again see like you can get a look at that flame chart and be like, are the things that I'm expecting to render or re-render actually doing that in this case, right? One thing I'm curious about too, just to look real quick, is I would expect an individual item isn't. They're getting a new update and remove. So could we make this better? I think we could. Let's do it. All right, as I said before, we get a new update. If we pass either set items or dispatch all the way through, like those stay static, they don't get regenerated based on items, right? But then the problem with passing set items through is what does it need? I mean, theoretically, it needs a list of items unless we use the function callback. So let's set items through or dispatch all the way through. Like those stay static, they don't get regenerated based on items, right? But then the problem with passing set items through is what does it need? I mean, theoretically, it needs a list of items unless we use the function callback. So let's do it. I can do it either way. We'll get the same effect. Let's do it with a reducer, but also passing set items through and using the function callback would work. So check it out. It's almost like I had pre-baked reducer. It does all the things that you think. It adds stuff, it removes stuff, so on and so forth. So in this case, what we'll do is we'll change this to useReducer.
You're going to pass useReducer.
I'll give it that get initial items, which is literally just returning a JSON array. I don't even know why it's a function. And so this becomes called items. Yep, and we'll call it dispatch now. Now, dispatch just fires actions. It doesn't actually need to know what the current items are. It's just saying like, hey, this item, we're toggling it, right? And the reducer gets everything and figures it all out, right? As we know that set items, if we still had it, you could do this as well. It's really like, they are, you know, set state being or useState being an abstraction over useReducer. It's not even like, even to call them different things, you could do either way. It's different flavors of the same way. This would give you a reference to the current items that you would not have to pass through. But I think, like, yeah, no, you could do it. Like, you could do it for some of these and make it all kind of happen, right? I'll leave that one as access to read it. Let's do the useReducer because it's just different and I can make a point. And you can do stuff with the items here. So now we're going to pass dispatch all the way through, which means really I get to do one of my favorite things in the world. Can't delete the two lists. That one. And we can see that instead of passing all these things through, we literally just say, awesome. Do it here as well. I'll pass it through the others. I'm probably only going to do the two lists in front of us because like it's just variations on a theme. So we'll pass it to item list. In item list, we will go ahead. Really didn't need that in another pane. We'll swap out the fact that we're giving it update and remove and just give it that regular old dispatch. And notice I got rid of all those use callbacks that I wrote. They're gone, right? So by definition, like this is going to be slightly better for us. And then the individual item, setting it update and remove. I literally have it on my clipboard. Cool. And then we'll go down one deeper, get rid of it again. Now, insofar that I'm very lazy, the action creators have the same names, so I just need to import them. So now the only thing coming through is dispatch. So that now wraps each of these.
So you need to wrap it.
These will dispatch those objects. It doesn't need to know anything about the items. It's just telling the reducer, hey, they said they wanted to remove the one with this ID. The reducer's like, yeah, I got all the items. I'll figure it out. I think that I'm like accidentally getting myself like the reputation as like a reducer fanboy, and I'm here for it. I don't have a problem. So let's check it out. You see that I don't have the individual items flashing anymore, and we'll verify that in the tools. Right, like, sure, the first time it was rendered, like probably once it changed, but you can see at this point, like, it is not re-rendering them because they're getting the same dispatch, they are the same item in memory. Because just because you change something, the array is different. All of the objects in that array are the same ones unless you change them. Right? That's part of the promise of like the immutability. It's the same object. So that was fine. Just because it was a new array full of objects doesn't mean the objects were different. It's just a new box that they're in. And so we got rid of all the use callbacks that we just installed. All we have is that React memo that we had in the very beginning. And yet we actually stopped an entirely additional, like removing a use callback and taking a different approach was more performant than using the use callback, right? And that's like kind of a running theme that we have today, which is like, sure, these tools are great, but are they the best one, right? Sometimes they are the right one. Sometimes the trade-offs are worth it. But just being like, oh yeah, I have to do this blindly every time is maybe not always the best way forward. And like we could do it with set items too, right? Like, let's go for a quick bonus round. So we had useState. That should give us what the get initial items that we put in a function because we learned something earlier. This is now set items.
So we to recreate that state.
So in this case, we'll now change this. The joke I made the other day, which is if I'm anywhere near a 10x developer, it's because multi-cursor. And if you hit some of the ones, so in this case, we'll now change this. The joke I made the other day, which is if I'm anywhere near a 10x developer, it's because multi-cursor. The joke I made the other day, which is if I'm anywhere near a 10x developer, it's because multi-cursor. And if you hit some of the ones I didn't fully wire up the dispatch with useState, they will break, so just don't hit them. Cool. You can pass all these through. Now what we should be able to do as I go off-roading is swap it in here. And these are going to be slightly different now. I have those helper functions that we're using. So this was what, update items. Now this now gets, we'll give the function version where it's like all the items. And that takes all the items. The reason I wrote these in TypeScript was so that I could have help. The current item.id. What's the other one? And I need the updates. So in this case, this is just packed, and we're switching it. I'm only going to wire up this one just to make the point. Grab the event. Cool. Actually, we want just the opposite of whatever it was, just like we had before, right? For a name, we might need that all, but like we're just toggling this. All right, so I half did this, so we'll see, and then I will take Mark's question. Oh, we broke it. Mark, what's your question?
Why does useReducer work better than useMemo and useCallback?
Because it is. We broke it. Mark, what's your question?
Why does useReducer work better than useMemo and useCallback?
Because it doesn't need to be used in useCallback at all. useCallback is a way to say.
Does useReducer work better than useMemo and useCallback?
Because it doesn't need to be used in useCallback at all. useCallback is a way to say, hey, don't give me a new reference to this function for these reasons. But if any of those reasons change, I need a new version of this function. Dispatch is always the same one, right? It doesn't ever change. It is from the very beginning of when you call that hook, it gives you a dispatch, which will always be the same dispatch. So it eliminates your need for useCallback completely. The only reason we needed useCallback is we were whipping up functions on the fly. If we were willing to pass down, like either the set items or dispatch, basically they're effectively useCallback way before we ever got it, right? Here we're taking something that was already useCallback and wrapping it in another one, right? So it's not necessarily that like they're better morally. They're just like doing things less is better than doing it more. Yep.
Is there any performance advantage in using Redux over how you're using the reducers here?
Yeah. So like everything, it depends, right? Let's see, like, also I called it name for some reason. We're doing packed on this one. That's what happens when I talk and type. But so yeah, the question was, is there advantages to using Redux? So there are advantages to using Redux. right? useReducer is great. Awesome. You get a reducer, you get dispatch, cool, cool, cool. Things you don't get, middleware. Things you don't get, Redux DevTools. A few other things. Things you don't get is like all of the TypeScript support that's built in React Redux. When we, imagine once we get this thing not rendering, that we're going to pull it, just hypothetically, that the next section was like, let's wrap this thing in the context API, right? You will see that all of the performance gains that we got immediately go away, right? We'll get them back by doing a bunch of work, right? If you were to then do the same example as an exercise as a reader later and just grab React Reader, just the simplest version, you would see that you would have all the performance gains out of the box for free, right? For two reasons, right? Some of them are newer reasons than older reasons, right? For two reasons. One is that those performance gains have been done for you. Two is that modern React Redux, at least the current version, I don't know when this changed, but I verified it by looking at the source code a week or two ago. It doesn't use the context API. It uses that sync external store. I literally almost typed it a second ago. And it uses that, which is because by definition in React, that useReducer is a hook, which means it has to be defined in that function, which means the store, at least, or that state, is new every time, right? You think about when you set up Redux, you're saying out even before you did your first component, even before you created that root, you're create store, right? So that is a static object that is just floating there, the same one in memory. It has a getState method and a subscribe, which just gives tells you to call getState, where it'll give you the newest and most immutable version. If that state hasn't changed, you automatically get the same object as you got last time. It's only if it changed that you get a new object. The store itself isn't going to change because it's in the initial scope that you defined it in. So it is just simply it's better insofar that useReducer doesn't seek to be a complete replacement. It seems to be in that there's always there are certain distances that you will definitely walk to, and you'll be I'm not taking a car there, right? And then after a certain point, you're I'm gonna either get the bike or the car or something like that. And I think useReducer is I need a little bit of a reducer. I need something where I've got a form and multiple things changing. And I'm deriving the state at the end. Pulling in Redux at this point feels a bit much, right? Or what have you, state management library of choice, right? I like Redux, cool, cool, cool. You might like MobX, what have you, cool. But there's usually sometimes it's is it really time for this yet? Yeah.
Yeah, why not combine both? Let's
Okay.
say just use Redux for the global part and use Reducer for the forms or individual pieces where you don't feel like exposing them globally.
Exactly. That was the point I was going to make.
Let's say just use Redux for the global part and use Reducer for the forms or individual pieces where you don't feel like exposing them globally.
Exactly. That was the point I was going to make. So I'm going to repeat it like it was mine.
I misunderstood. Maybe originally I thought what you meant is it's either or.
It's not either or, right? And so one of the things we talked about in a different workshop together was different types of state. There's your kind of your model, whatever the business logic is of your application. That's stuff that a lot of times would go into the context API in some cases, or in Redux. And then there's is this form valid, right? You're not going to put that in your Redux store. At the same time, it might have enough complexity that you don't want 17 set states, right? Or use states in there, right? And so you're I can just use one reducer that checks all the fields and figures out one list of all the errors. Something along those lines, right? Every time I've ever grabbed a React form library, it is about a week before we throw it in the garbage and just write a reducer that grabs all the values, tells us all the errors that we can unit test and call it a day, right? And so yeah, for that ephemeral state, is this accordion open or closed? Is this form valid? I would probably use Reducer every time, even if I had Redux in the code base, right? I think it's a yes and. So yeah, for that ephemeral state, is this accordion open or closed? Is this form valid? I would probably use Reducer every time, even if I had Redux in the code base, right? I think it's a yes and. But as I was talking and typing at the same time, I just named it name instead of packed. And so it's yeah. You can see that without a single use callback, the React memos are still in there. Without a single use callback, I'm not re-rendering all those items. And just to keep myself honest, you see that we get all of the performance gains that we had before. So again, the major point here is that there is not one, you have to do it this way all the time, right? There are different trade-offs. There's different things you could choose to do. If I had to nest that through a whole bunch, right? Maybe I don't want to do that anymore. Maybe, hey, the act, maybe I got to go 38 components. And sure, maybe it is more performant to do that, but there's a likelihood that in the next month, we're actually going to have to move that box over there, right, in a different part of the subtree. And you measured the context API, which we'll look at in a second, and had no memorization or whatever, and it's still wicked fast, yeah, do that, right? Like, I'm not saying don't use the context API. I'm not saying don't use these things. I'm saying like, definitely think about it. Definitely consider the options. Do the thing that just says React naturally first, right? Or at least consider that first before like starting to cache and memorize things. Because yeah, the second you're caching values, if you mess that up, you will get those weird bugs that you cannot recreate. And I say that as somebody who has lost days of my life not that long ago. Embarrassing to admit how long ago. Like within the last month or two, to like little things like that, because yeah, it seemed more convenient at the time, and now I have these squirrely issues, and it's just never worth it. And so it's worth considering all the options, what the trade-offs are. You might still choose to use useMemo, useCallback, React.memo. Absolutely. My job is not to tell you which one to do all the time, because there's no point. I just give you a list and I'd walk out of here, right? My job is to basically like, here are the considerations, like all the things that could have been done by the compiler, the framework, whatever, the computer itself, the microprocessor have been done. We're left with like the weird squishy trade-offs that like could go either way. Like that's in our day-to-day jobs, the problems that we're left with, right? Cool. All right, so we had one question from the chat and then one question from the room. So the question in the chat was, can I repeat what the main benefit of switching to useReducer? I'm taking that over useState. To be clear, like if you're willing to pass useState down and you can deal with like what you're getting in the function callback and not wrapping additional like functions in that top level that you need to have the memory reference to, like useState is just a abstraction over useReducer. They are functionally the same, which means it comes down to a matter of taste, right? With useState, you have just that one item that you set in the very beginning. Could you set it to an object with multiple values? You could. At that point, are you almost just re-implementing useReducer with useState, which is on top of useReducer? You are also doing that, right? But in terms of like technically and functionally, it's purely a matter of taste, right? That set items or whatever, that was static, right? And the same thing, dispatch is also the same. I just like having one dispatch where I can have a whole bunch of things that are derived from that. I personally, and I can pull that function out and unit test it super easily. I personally like it. And I can just like say, hey, this thing happened. Here's all the information you need and cast it away instead of doing it in my UI layer. That is not a performance hack. That is simply, I think the pattern is really good. And then also dispatched it, and it's just one function. It's always the same. It's the simplicity of it causes me to make better performance decisions, and I don't feel like I'm giving anything up, so I like it. But like, I don't feel like, if you were like, no, I really want to use like useState, I'm like, okay, that's fine. Alex, you had a question.
Yeah, notice in the flame graph, the leafmost items such as the leafmost components do not contain the pure HTML elements there for renders.
Yep.
Can you address that?
Yep. So yeah, the question was basically we only see components in here, right? And that's kind of like a subtle nuance to one of the kind of graphs that we saw in the very beginning. Is the way that like it works is like components get rendered, right? Because like they have logic in them, right? And so React goes through each one, renders them, runs through the logic, gets the output, and like keeps moving along. Even if you like ever take JSX and like look at the compiled code, it's like JSX.create element, so on and so forth. It's like we all tried in like 2014 for a hot minute to be like, I'm not using this JSX thing. I'm going to write it in regular JavaScript. And we all did that for a good day, right? Or maybe two if we were really stubborn. So you can see what it looks like. But those aren't actually functions. They're just strings at that point. And so like for React, that is a dead end. Like as soon like it does not continue going down those. They don't, like if you think about what we saw with like the children, right? They don't really have any logic in them. They have children which belong to the parent component. Right? That same thing that we saw with the pulling the content up is true, but they also are not functions. So React is not working through them in the rendering cycle. That is the end of the line of each one of those trees. So as soon as you get to the final component that is only HTML elements, it is game over. But they are not rendered per se. They're not going through this entire process of comparing a button with X, Y, and Z things. It's just going to turn into the same effective data structure, the same AST every time.
You talk a lot of shit.
We've made promises about the context API, and I feel that it is my civic duty to keep those promises. So
you talk a lot of shit. So that'll be it for this video. Take care. Bye-bye.